Good morning everybody. Now I will start the next component or maybe last component of the module 1. So, first of all I will try to focus on the what is the effect of the surface active elements. So, you know in welding process that apart from the conductive heat transfer that actually happens within the weld pool, there is a considerable amount of the material flow or maybe fluid flow occurs within the weld pool. So, in that case that fluid flow actually takes a major role to determine the fusion zone shape, and most of the cases we normally neglect this fluid flow effect, and we always try to do the heat transfer analysis by using the only heat conduction happens within the weld pool. So, that means we generally assume the stationary molten weld pool, but very intuitively if you look into in depth the analysis of the weld pool, the molten metal that actually flow one specified direction, and that flow actually driven by the different driving forces, mainly the surface tension force is the mainly responsible for the liquid metal flow within the weld pool, and of course indirectly that flow also other way affect the shape and size of the weld pool. But there is a one question is that composition of this molten pool sometimes play an important role, the nature of the material flow within this small weld pool. So, one of the such interesting elements of analysis in the material flow, that is called surface active elements. So, in simplified way, surface active elements actually influence the surface tension force. The surface tension force means between the liquid molten pool and shielding gas, the surface tension force act. So, now we will try to look into the what is the nature and the direction of the surface tension force, and how this surface tension force actually influenced by the surface active elements. And of course, this indirectly the surface active elements influence us, changes the magnitude of the surface tension force, and that surface tension force actually influence the nature of the material flow. So, of course, the main factor or main driving force for the fluid flow is the surface tension force, apart from the buoyancy force, or if in arc welding process if there may be the effect of the electromagnetic force, or there may be effect of the plasma force that comes from the creation of the arc, that actually influence, but the influence of the plasma force, buoyancy force and the electromagnetic force may be less impact on the material flow, but surface tension force is the most important driving force or most significant force that impact more on the material flow. So, definitely not only the surface tension force, rather it is better to say the surface tension gradient, because the surface tension gradient also depends on composition of the metal. Not only that, also it depends also the temperature. So, it is as a function of the composition as well as temperature. Now, sometimes the small concentration of the surface active elements actually affect the weld pool shape. For example, if we consider the pure iron, and for example, if we consider the steel, and if we assume the steel is having the binary system iron plus one surface active element. So, between the pure iron and this binary alloy of iron, that actually in these two cases the nature of the material flow can be differ depending upon the presence of the surface active elements in the second case. So, small concentration of these surface active elements actually affects the shape of the weld pool in the way by simply changing the or altering the surface tension gradient. This is one way, or then surface tension, when there is a change of the surface tension gradient, and there may be the changes in the direction of the fluid flow in the oil pool. So, when there is a change of the direction of the fluid flow in the oil pool, that actually influence the shape of the oil pool. But in the composition, there may be some impurities which are not actually surface active elements, that may affect the oil pool shape in the way that impurities actually can react with the surface active element, and they can form some other compound, and that compound can prevent the action of the surface active impurities by simply changing their concentration gradient, or simply changing their concentration of the surface active elements. So, that way it may be a complex phenomena, but if we try to analyze the effect of the surface active elements, we consider that it is a binary alloy system. So, based on that, it is easy to explain the effect of the surface active elements. Definitely surface tension is always a function of temperature. So, that temperature dependent. So, that surface tension force, we need to another two point of view, one is the concentration dependent assuming, as well as the temperature dependent. So, based on these 2 points of view, we can try to analyze the effect of the surface tension force. So, that magnitude and the direction of the surface tension gradient, that actually influence the material flow within the oil pool. So, in single term, that is called the material flow within the oil pool is that is called the Marangoni convection. So, normally what happens, the Marangoni convection mode, in this case, if you see the first case, the first figure, that surface tension actually decreases with increase in temperature. So, that means surface tension for decreasing with increasing temperature. In case of welding process, exactly at the center point, temperature becomes the maximum, and away from this center point the temperature actually decreases. So, that means there exists some temperature gradient from center to the outward periphery of the oil pool, and accordingly the surface tension also varies from that nature of the surface, direction of the surface tension force depends on this variation of the temperature. So, that can be represented, that temperature and the surface tension in this figure, that the gradient actually is a negative gradient. So, in this case, the presence of this negative gradient actually creates the normal oil pool, normally having the width is more and depth is less in this case. Now, what happens? So, without any presence of surface active elements, this is the normal behavior of the material flow within the oil pool, that can be represented the negative slope of the surface tension, with respect to temperature, and then it creates the normal oil pool. But what happens if some small amount of the surface active elements is added, that actually change the surface tension temperature coefficients to a positive value. So, adding of the surface active elements is basically change the slope from negative to positive slope. So, when there is a change of this slope, that typical nature of the behavior of the surface tension force or surface tension gradient is basically impact on the nature of the material flow. So, in this case, if the second case, what happens? Since the surface tension, the gradient changes from negative to positive gradient, then accordingly the shape of the oil pool changes. So, in this case, the oil pool become narrower, the width becomes narrower, but depth actually increases. So, other way we can say, in the second case, probably it is more advantageous if we try to achieve the high depth of penetration. So, as compared to the wider width. So, second case, the aspect ratio also increases in respect to the first case, as well as the penetration also increases in the second case. So, in the second case it is more desirable, and that comes from simply basics, simply adding some amount of the surface active elements. But of course, the quantity, the amount or the concentration of the surface active elements also having some role. Not any amount of the surface active elements can change this surface tension gradient from negative to positive. So, what we understand from here, that basically the presence of the surface active elements, that actually overall it is affect the direction of the material flow, and that actually influence the change of the oil pool size and shape. So, this two types of mode that is called the Marangoni convection mode probably we observe in the oil pool. Definitely the surface tension of most of the liquid metals is substantially basically altered or changes by presence of the small amount of the surface active elements like oxygen and sulfur. Normally practically observed in steel, presence of oxygen and sulfur is certain quantity that actually acts as a surface active elements, and they alter the surface tension force and the mode of the material flow, and finally the affect the size of the oil pool. Now, presence of the surface active elements or agent in the liquid metal is significant, and that is better represented by the temperature gradient of this surface tension force, and that temperature gradient of the surface tension force that actually changes from negative to positive changes, and depending upon the presence of the surface active agent in this case. So, the Marangoni convection, the flow of the Marangoni convection within the oil pool, that actually influence the oil pool in presence or absence of the surface active elements. So, one example is that presence of the sulfur and oxygen in steel normally observed in specifically stainless steels acts as a surface active elements. So, one practical example of the surface active elements we observe that 180 to 600 ppm within the final oil pool, presence of oxygen in SS 304, that means stainless steel 304 grade stainless steel, produce the maximum weld penetration with a certain specific welding condition. So, that means there may be some optimum amount of this surface active elements that then we can get the maximum benefit of the, we can achieve the maximum weld penetration. But if we further increase the amount of the surface active elements, it does not influence the surface active agent in this case. So, we cannot increase penetration too much, and if we abruptly increase the amount of the surface active elements, but at the same time if the very small quantity of the surface active elements also may not be beneficial to increase the depth of penetration. So, this optimum amount practically observed that it actually gets the maximum benefit of the maximum penetration can be achieved.